Hey guys, today's question is maximum matrix sum. In this question, we are given with the n cross n integer matrix and we have to determine the maximum matrix sum, and we can do some operations, any number of operations on the matrix. In that operation, we can choose any two adjacent elements horizontally or vertically, that's our choice, and multiply each of them by -1. Okay, so if the element is 1, it will be turned into -1, and if the element is -1, it will be turned into 1, and so on. Okay, two elements are considered adjacent if and only they share a border. That's same. Your goal, our goal is to maximize the summation of the matrix element. Okay, so we have to maximize the summation of the all matrix elements. Okay, so let's understand by the example. So in this example, here we can see there are two negative elements. So first we choose these two elements, so this -1 turned into +1. Okay, sorry, first we choose these two elements, so this -1 turned into +1 and this one turned into -1. Now then we again choose these two adjacent elements, so these turns into positive ones. Okay, by multiplying by -1. So after doing all the operations, the overall sum will be 1 plus 1 plus 1 plus 1, which is 4. Okay, now in this case we can see the number of negative integers are odd. Okay, here there's a point to note. So there is no way that we can change all the negative elements into positive ones. Okay, there's no way for that. So like if we choose these two elements, these will be turned into 2 and 3, but we can't choose any more element with this -1 to turn this one into positive, and the rest number will also change into negative if we choose this element. Okay, so what to conclude by seeing the example, and you can notice that if the number of negative elements are odd, then there will be at least one negative element that will be remained after all execution. Okay, wait a sec. Okay, so we concluded that if the number of negative elements is even, then we can change all those elements into positive ones by doing, because number of operations have no limits. Okay, we can do any number of operations. And if the number of negative numbers are odd, in that case there must be one negative element remaining in that array after doing all the operation, and will we will greedily choose that element that is smaller, because we have to maximize the matrix sum. Okay, now let's see one edge case here. Like for this example, minus, you can as you can see, you will calculate the matrix sum and you will see that -2 is the minimum. So, and the number of negative integers are also odd, so we can't change this -2 into any element that is greater than this. Okay, so but here what we can do is we can choose these two elements, the 1 and -2, and if we apply the operation in these balls, so this -2 will be changed to plus of 2 and this will change to minus of 1. Okay, and you can see that this is a better answer for us. Okay, by doing this our maximum sum is more than the previous sum, because -1 is smaller than -2. Okay, sorry, -1 is greater than -2. Okay, now another case is, what if I have a negative but I have a 0 here? So if I have a 0 here, that means I can choose these two elements, so this -2 will be turned into the positive 2 and this 0 will be -0, that is same as 0. Okay, so if there is any 0 in the array, that means we can maximize the sum by, we can remove all the negative elements and turn them into positive ones. Okay, uh, that was the whole approach. Let's code it to understand well. Initially let's take the sum as long sum equals to 0, and to take the modulus and the end to whether check if the all numbers are negative or not, so we will take negative count, that will store how many elements are negative, and let's take a minimum that we have to, that if the negative count modulus 2 is 0, then in that case the minimum will be the minimum element in that array, and we have to subtract it twice from the total sum. Okay, so mini equals to int max. Now after this let's iterate in that array, so let's traverse the 2D array. So for int I equals to 0, I less than matrix dot size, and I plus plus. Now for int j equals to 0, j less than matrix 0 dot size and j plus plus. Now we have three conditions. The number can be positive, can be 0, and can be negative. So initially we will just simply add the sum, the absolute value in the sum. Okay, so absolute of matrix ij will be added to sum. After this, we also have to track the minimum value. So mini equals to minimum of mini, comma absolute, and we don't need to write any other case for the if the element is 0, because this minimum will already include that 0 element. Okay, so mini equals to minimum of mini, comma absolute of the current value, which is matrix ij. Now we have to increment the counter of negative counts only when we encounter a negative element. So if matrix I j is less than 0, then we increment that negatives counter plus plus. Now after this, if the negatives count is modulus 2 is not equals to 0, that means there are odd number of elements which are negative. In that case, we have to subtract twice an element that is the minimum negative, which will be in the mini. Okay, for example, in this case we will add all these elements in their absolute form. So this will sum into, I think, 1 to 3, 1 to 3, 1 to 3, which is 18. Okay, after that 18, we know that we have to decrement -1. Okay, but we have already taken a positive one, so we have to decrement it twice. Okay, so we will write -1 again. Okay, so first case, if the negative count modulus is 0, modulus 2 is 0, that means the number of negatives element are even. In that case, we can change all elements into positive ones, so we will simply return the overall sum, and in the else case we will return sum minus twice of mini. Okay, but here it is a one problem, that the element can be 10 to the power 5, so 10 to the power 5, okay, so there is no problem, sorry. So sum minus 2 times mini. Okay, uh, that should work. Let's run this. Okay, let's submit. So the code is accepted. Thank you for watching.